In a network, your data knows who it wants to talk to logically, but not where they are physically. To bridge this gap, you need an identity map. Enter ARP and RARP. One is the daily worker of the internet. The other is a ghost from the bootstrapping past. To understand their duel, we first need to look at the direction of the query.
The fundamental difference is simple: direction. ARP starts with a known IP and asks for a MAC address to deliver your data. RARP does the exact opposite. It starts with a known MAC and begs the network for an IP address. Knowing the direction is just the start, but where is this mapping data actually stored?
This is where their architecture diverges. ARP is decentralized. Every device maintains its own ARP cache, learning and updating local tables on the fly. Our ARP, however, is centralized. It requires a dedicated RARP server, a central brain holding a master list of hardware to logic bindings. With the data stored, how do these protocols actually serve the device's lifecycle?
Their why defines their use. ARP is for active delivery. It runs every time you send a packet. RARP was designed for initialization. It allowed diskless workstations to boot their identity from the network because they had no storage to remember their own IP. Utility dictates survival, which explains why one of these protocols is now a legacy ghost.
Why do we see ARP everywhere, but rarely RARP? ARP remains mandatory for IPv4. RARP, however, was too limited. It couldn't provide subnet masks or gateways. This led to its replacement by BootP and eventually DHCP. ARP stayed vital, while RARP evolved into the dynamic configuration we use today.
Identity mapping is the silent engine of your LAN. Master the flow, master the stack. Follow Beta Growth Tech for more deep dives into network architecture.